Hello friends, welcome to this session about blockchain technology. There are many learning materials about blockchain technology available today in the internet, and hence I am not trying to replicate the similar content in this video. Just as a recap, I will brief about the fundamentals of blockchain technology, its evolution, a little bit about DApps and blockchain applications, current market status, and then we'll talk about the leading blockchain products and services available in the marketplace. So what is a blockchain? If you have done some analysis about the blockchain technology, the first thing you might have noticed its relationship, or probably you got confused with the popular cryptocurrency Bitcoin. That is because people started noticing about the blockchain technology after the successful implementation of Bitcoin protocol on a blockchain. The key thing to understand here is that Bitcoin merely uses blockchain as a means to transparently record a ledger of payments. But in theory, blockchain can be used to immutably record any number of data points. A blockchain-like protocol was proposed by a cryptographer David Chow in 1982, and further work on a cryptographically secured chain of blocks was described in 1991 by Stuart Haber and W. Scott Stonetta. Their intention was to implement a system wherein document timestamps should be protected from tampering. Then the first decentralized blockchain was conceptualized by a person or group of people, the fact is still unknown, named as Satoshi Nakamoto in 2008. The success story of Bitcoin created a lot of interest in its backbone technology blockchain and started thinking about its adoption in other business areas. The main attraction about blockchain technology is that the transactions are copied and stored across individual computers on the network rather than storing on a central server. This is known as distributed ledger technology, in short DLT. In simple words, blockchain is a shared distributed ledger that stores data and records its state changes. Let's see how blocks are getting created in a blockchain. First of all, a user requests a transaction. The transaction is then transmitted to a network of peer-to-peer computers scattered across the world. This network of computers then solves equations to confirm the validity of the transaction. Once confirmed to be legitimate transaction, they are clustered together into blocks. The blocks of transactions is then chained to older blocks of transactions. Finally, the transaction is completed and current block is permanently added to the distributed ledger of transactions. These blocks of records are copied to every participating computer in the network, so everyone will have access to it. To understand the internal working of blocks, I highly recommend to visit this blockchain demo created by Anders Brownworth. The URL is andersbrownworth.com/blockchain. Here he has clearly explained about the hash, what is inside a block, how the blocks are chained, concept of distributed ledger, tokens, Coinbase. This is very interesting. You can get a fair idea about the blockchain by seeing these videos here and then trying these implementations by yourself. Let's now understand the transaction validation process. As you know now, the asset and its transactions are stored as a connected blocks in blockchain. Only the valid transactions are added to the blockchain. Whenever a transaction takes place in the blockchain, it will be added to the block. Sometimes one transaction per block and sometimes several transactions per block. It depends on the block size and nature of the network. As I mentioned before, to add a transaction to the block, it must undergo a validation process. This validation process is implemented using consensus algorithm. The goal of a consensus mechanism is to have a system that allows them to first agree on a single version of the truth and then record that agreed upon truth in their ledger. In other words, consensus algorithm is a procedure through which all the peers of the blockchain network reach a common agreement about the present state of the distributed ledger. Different blockchain uses different consensus protocols. These are the different consensus algorithms currently using in different blockchain platforms. I'm not going in detail about each of these algorithms here, but if you are interested, you can explore more about it and understand how it is working. The important thing you need to understand here is that there is a stringent and a reliable validation process before adding a transaction to the block. Another important topic I want to summarize here is about decentralized applications or DApps. DApps are getting more and more popularity since the last 3-4 years and serving as the focal point of massive blockchain adoption. For a traditional web application, there will be a server owned and operated by an organization or an individual, giving its full authority over the application and its working. DApps are applications that run on a decentralized network of computers instead of relying on a single server. Major challenges with the dApps are in developing a user-friendly interface, difficulty in modifying deployed code, and scalability issues. There is a very good website to see the dApp statistics, stateofthedapps.com. Here, go to stats page. You can see the total dApps. Currently it is more than 4,000 applications are running on different blockchain platforms. Daily active users, 24 hours transactions, volumes, number of smart contracts. Here it is showing the new dApps added per month. And this black line shows the total number of dApps. See the count keep on increasing. You can filter this by platform. Majority of dApps are developed on the Ethereum platform. Filter by category. You can see all the categories of dApps built on the blockchain platforms. The next section showing Ethereum dApp activity statistics, number of transactions in each category like development, energy, exchanges, finance, etc. Here showing blockchain platforms used for dApps development. Majority of the applications are running on the Ethereum blockchain. Here it is showing different statuses like how many dApps are live, how many are abandoned, currently in beta, work in progress applications, etc. You can explore more in this website to have a better understanding about the dApp statistics. Let's move on to the next topic. It's about blockchain platform for application development. The application specified here is not about dApps but blockchain-based applications. This can be web application or applications that are running on the end user devices. These applications and services interface with the blockchain platform using the API offered by the platform. These nodes, which are interfaces to the blockchain, expose APIs that are consumed by the client applications. These applications may have access to other server-side resources such as databases and services as needed to implement functionalities. These are not at all related to blockchain, but it may be required to implement business functionality. I believe you got a high-level understanding about the blockchain applications architecture. There are thousands of blockchain products or platforms available in the market today to build your blockchain application. The most popular blockchain products are Ethereum, Hyperledger, IBM Blockchain, Corda, Ripple, Microsoft Azure Blockchain, Oracle Blockchain Cloud Service, Stellar, etc. The first blockchain application, Bitcoin, was created only for the cryptocurrency transactions, but the second largest blockchain platform, Ethereum, was proposed to utilize blockchain technology not only for maintaining decentralized payment network, but also storing computer code that can be used to power tamper-proof decentralized financial contracts and applications. There are many companies working on commercial blockchain products today for various business domains like finance, manufacturing, media, healthcare, transportation, construction, real estate, so many. I think you are familiar with IT services terms like software as a service, platform as a service, infrastructure as a service, etc. Similar way, companies like Microsoft, Amazon, IBM, Oracle, R3, Paste, etc. are providing cloud-based infrastructure and management for building and operating blockchain application under the category of blockchain as a service. This is based on the SaaS model and work in a similar fashion. As you know, SaaS model is a cloud-based software delivery model where software is licensed on a subscription basis and is centrally hosted. In blockchain as a service model, service provider companies usually use open source blockchain products like Enterprise Ethereum, Hyperledger products, Corda, QRM, etc. and customize to make it scalable and secure to ensure the best running of the network. You will be provided with a user-friendly UI to set up and configure your blockchain without knowing any underlying technical details. This will transfer the technical complexities and operational overhead involved in creating, configuring, and operating a blockchain to the service provider. This model works well because consumers and businesses are increasingly willing to adapt blockchain technology, but the technical competency and operational overhead often act as a barrier. Next, we will move on to the blockchain classifications. There are three types of blockchains: public, private, and hybrid. Public blockchains are completely open to public and anyone can participate as a node and also can perform transaction verification. Public blockchain is secured with proof of work or proof of stake. Most popular public blockchains are Bitcoin and Ethereum. Private blockchains are not decentralized as public blockchain. Only selected nodes can participate in the process, making it more secure than the others. The private blockchains are open only to consortium or group of individuals or organizations that has decided to share the ledger among themselves. Popular blockchains under this category are Hyperledger and Corda. In hybrid blockchain, part of the blockchain is private and a part of it is public. The private part is controlled by some organizations, whereas the public part is open for participation by anyone. It provides best solutions to the business domains like energy, agriculture, healthcare, construction, supply chain, government, real estate, financial services, etc. It provides a solution where data needs to be accessed publicly but need to manage privately. Examples of hybrid blockchains are Ripple Network, XRP token. Choosing a right platform based on your requirement can save you a lot of time and pain down the line. There were some initial use cases which started the POC in Hyperledger Fabric and then later moved into Ethereum, and vice versa also had happened with some other use cases. For example, in the freight or logistics sector, ideation and POC started using Hyperledger Fabric but later shifted to Ethereum because of the process complexity and involvement of cross-border provenance required the use of public blockchain or the private one. The first consideration should be given in selecting the type of network, public, private or hybrid. Public network requires a payment in cryptocurrency to transact or run applications on the network. The biggest advantage of public network is that the infrastructure is already exists, so you are only building on top of it. The flip side of it is that you cannot exert any control yourself on the network, which means any bottlenecks due to its high usage will throttle your application's performance as well. This concern leads to your next criteria for selecting the blockchain platform, that is scalability and throughput of the platform. Another important factor you need to consider is the availability of the quality documentation and strength of the community. Developer availability is another thing you need to keep in mind. Consider how easy it is for a novice developer to get started with a specific blockchain. Give priority to the blockchain which are already proven as a success in the similar use case or domain which you are currently into. What is a blockchain decision framework? Based on the blockchain capabilities and lessons learned from experiences, different companies and individuals have come up with the many blockchain decision frameworks, which helps us to do a preliminary assessment and decide the type of blockchain suitable for the use case. Just because something can use blockchain doesn't mean that it should use blockchain. You should consider all the aspects in different directions. Here it is showing what are all the conditions where blockchain solution is not recommended and the conditions where private blockchain is the most suitable option. Similarly for public and hybrid. Keep in mind that these frameworks are just a guideline for the initial analysis only, not for taking a final decision. Good documentation, strong community support, and many success stories making these blockchain platforms more attractive and can be considered for your use case implementations. I'm not going into detail about each of these blockchain here, but you can select a few and see the use cases implementation details from the official website and GitHub repositories. There are many projects which are under development or production ready in supply chain domain. Consider the agriculture or grocery sector. Food safety is a paramount importance and so the ability to track and trace agriculture and grocery products. So this may explain why majority of the projects that utilize blockchain were concentrated in this sector in the initial phase of blockchain adoption. Freight or logistics is another area in supply chain where blockchain technology adoption is showing immense advantages. Consider an example, the complexity of moving products from East Africa to Europe required over 200 interactions and involved more than 30 individuals and organizations in the journey that had cost of paperwork exceeding 15% of the entire transportation cost. When considering the blockchain environment used, Ethereum has a much greater proportion of startups than any other products, but enterprises mostly prefer Hyperledger blockchain projects. This can be attributed to the different nature of blockchains. Ethereum is a public blockchain and relatively easy to fundraise with tokens. On the other hand, Hyperledger is more suited for private usage and therefore fits any enterprises or public companies. Now the business transformation using blockchain has spread across all the major industries like banking and financial services, automotive, healthcare, government, insurance, media and entertainment, telecommunications, retail and consumer goods, travel and transportation, agriculture and natural resources. As per the Forbes report, if you see the top 50 companies developing blockchain applications and providing commercial products and services to the customers, the most commonly used blockchain product is Ethereum. Next comes Hyperledger Fabric private blockchain. One thing I want to mention here about the two major issues currently with Ethereum blockchain, which are scalability and exorbitant gas fee for transactions. For any public blockchain network, there will be a transaction fee paid to miners in order to get a user's transaction to be included in the block. This fee is commonly known as gas fee and it is not a fixed value but keeps fluctuating with the time due to various reasons. Primary reason for this variation is due to the difference in supply and demand proportion. Currently, Ethereum can process only 13 to 15 transactions per second. The main reason behind Ethereum's scalability bottleneck is that each node in the network has to process each transaction. Nodes perform the job of verifying that the miner's work is valid and each node keeps an accurate copy of the current network state. There are layer 2 solutions like Polygon, Arbitrum, Loopring, Immutable X, Validium, Rollups, etc. to add Ethereum scalability issue. But the Ethereum Foundation has mentioned that after Ethereum 2 upgrade that is going to happen this year, transaction speed could increase as much as 100,000 transactions per second while maintaining the same level of security. This will raise a question about the existence of layer 2 solution after Ethereum 2 upgrade. As more and more applications are keep adding to the Ethereum blockchain and thus the user count, we can expect the role of layer 2 protocol will remain relevant. Thank you very much for watching this video. If you have any comments or questions, please let me know.